Okay, so this video is 2.7D, related rates, last video. You can put the date up here. And we're talking about example 5, changing angle in elevation. So far we've talked about related rates with like a ladder, and we talked about the funnel on the part C video. And you'll probably notice I made a mistake there, but hopefully you saw that I wrote in text over that. So that just happened earlier. Yesterday actually. So what I want to talk about today is what if we had an angle changing, and how can angles be in equations, right? How can you write an equation with an angle in it? I mean, a lot of you are coming to me from pre-calculus, so you might remember about SOHCAHTOA. SOHCAHTOA. So if you think about SOHCAHTOA, that's sine equals opposite over hypotenuse. So sine equals opposite over hypotenuse, sine of an angle, cosine of an angle equals adjacent over hypotenuse. So you put in an angle, you get out a ratio is kind of the idea here. And this question has an angle variabilized in it, and we're not going to be able to use Pythagorean theorem here. So that's kind of the warning. So it says find the rate of change of the angle. So right away, we know that if we're going to make a box here, that that d theta dt is what we're looking for. So find d theta dt, that's the rate of change of the angle, when t is equal to 10 seconds in, right? So we look at our diagram here, and we get some kind of important information over here, right? So this equation probably kind of helps take the time, and you can kind of get a position equation from that. So let's see if we can figure out what that means. When t equals 10, what does s equal? Well, s is going to equal, we have to take 10 and square it. It's 100 times 50. So I guess s is going to equal 5,000. Okay? So when t is 10, s is 5,000. And we see this equation, tangent of theta equals, right here, this is actually our equation for our dreads. It's kind of important. So let's just talk about this, okay? So we have dreads, so we have a diagram already done. We have the rates in a box. We need an equation, and I'm telling you that this is our equation. Tangent of that angle equals adjacent over hypotenuse. Well, adjacent to that angle, tangent is opposite over adjacent, my apologies. So opposite that angle right here, opposite is s. And adjacent that angle, just next to it, is 2,000. So TOA, opposite over adjacent. So the equation from the green box, now we can differentiate and then substitute and solve. So think about what the derivative of tangent is. Derivative of tangent is secant squared, but we need to chain rule that. So as soon as we derive, I'll put a red check mark here for when we've derived. So it's secant squared theta. Don't forget d theta dt. Okay. Now we need to derive this other side, which is really just 1 over 2,000 s. So it's 1 over 2,000 ds dt. So we've gotten a pretty good, we've definitely gotten close to what we need. We need to figure a couple of different things out. So how can we figure out other missing things here? We got to substitute some things in. We got to solve. I don't know what to do. So let's just pause the video and think about this for a second. What might you do in this situation? So if we're thinking about this, what I think is key here is this equation over here. I'm going to use blue to kind of show here. This equation, if I derive it, it tells me the following. It tells me that ds over dt is equal to 100 t. And this is with respect to t. So ds dt is actually 100 t because the variables matched up nicely. So that's a good thing. So we could actually put 100 t here. We put 100 t into the equation here. So if I do that, if I put 100 t in there, I have 1 over 20, because 2 of those zeros are going to cancel out, and I have t here. I don't really know what to do here, but I'm going to divide by secant squared. If I divide by secant squared, I'm multiplying by cosine squared of theta. So I've multiplied by cosine squared to get rid of the secant squared. So if I divide by secant squared of theta, it's the same as multiplying by cosine squared of theta. So now I know d theta dt is equal to all this stuff over here on the other side of the equation. So what does it seem is unknown? Well, t we know is 10, so that's a good thing. Cosine squared of theta we don't really know, but maybe we can get it from the triangle. So I want to say it's 1/2 because I put t is equal to 10, right? That's 10 from up above. Cosine is what we don't really know. So we want to know cosine of theta, and then we want to square that value, and that's going to give us d theta dt. So if we draw the triangle out, right, and we know the triangle looks something like this. Here's theta. We know that this was 2,000, the horizontal was 2,000. And I think we did some work to find out what the height was. We did it kind of up here. It was 5,000, so remember in the green box, you'll see 5,000, okay? And there's going to be a ton of work to get whatever this is. So let's just think about that for a second. You can pause and try to find it, see if you match me. So just pause. I'm going to find that right now by Pythagorean theorem. Okay, so hopefully you paused and kind of figured out what this was. It's kind of a disaster. I'm really sorry about this, but it is the square root of 29 million. Yeah, you'd think I'm joking, but I'm not. Okay, so let's enjoy ourselves and kind of use that for a second. So if we talk about this right here, cosine is adjacent over hypotenuse. So if we take the adjacent 2,000 and put it over the hypotenuse, which is this 29 million in the root, we square that and we take a half of that, we should get whatever d theta is dt in radians. Make sure you use a calculator for finding this, obviously, and also make sure your calculator is in radians. And you really want that always in this class. In your physics classes, a lot of times it's going to be in degrees, but unfortunately we need to be in radians for these types of problems. So all of this is kind of a mess. What it kind of winds up being is 0.069 if you round it. 0.069 radians, radians per second. Now the units I didn't do a good job of talking about, but we know it's going to be radians if we keep our calculator in radians and we're working with everything in kind of pure math. And if we go back up, we kind of see like things are happening in seconds here. So we can kind of go back and kind of look through and say, okay, we knew it was happening in seconds. So this was actually a pretty tricky introductory problem, but let's take away the big thing, okay? The big thing is being able to write an equation with trigonometry in it by SOHCAHTOA, okay? And then being able to derive that equation and plug in for what you don't know. But what's weird also is this part right here. Finding cosine of theta, you have to go back to the triangle and figure it out. So pause the video and give this one a try. It's kind of a similar problem. We got a similar situation. We got two planes moving. If you talk about the way that they're moving, like if we talk about the speeds that they're going, we're really talking about the rates at which they're moving. So think about that for a little bit. At what rate is the distance between the plane decreasing, which is s, so ds dt, which is probably going to be a negative because it's decreasing. And then, yeah, just do the best you can do. And then lastly, we'll go to this problem here. A balloon rises at a rate of 4 meters per second from a point on the ground 50 meters from the observer. So let's just try to talk about this a little bit together. This is 50 meters from the observer. Here's the angle. And we know this is y. And I guess if this is the case, right, and they're saying that it's going at 4 meters per second off the ground, right, I'm going to say dy dt is 4 meters per second. Find the rate of change of the angle of elevation. D theta dt is what we need when, and that's at a certain time, when y equals 50. When y equals 50. This is actually a much more reasonable problem. We can use Pythagorean theorem to find z if you want, but you're definitely going to need to use a trig equation with the theta here. So regardless of how the last question went, because I think the last question is a little harder than this one, try this question. Mimic what we did in the previous question on this video. I think you'll find it a little bit easier. So you either use sine, cosine, or tangent to write an equation. We have diagrams, we have the rates. Then you're going to derive that, and then use a little bit of your basic trigonometry, remember that this is a right angle, to solve this thing, okay? So this is going to be another now you try, NYT, now you try. And hopefully this helped. I know that last question was kind of tricky, but the big idea was highlighted there. So let's go back and just see what you can do. Right here is kind of important, just a little note, so please read that. And I'm going to end this video nice and short. Good luck on those problems. I will see you in the next video. Peace.